So welcome to our talk. It's called Java on Guicing, Guice, Java on Juice, dependency injection, the Java way. I'm Bob Lee.
I'm Kevin Bourrilliion.
Not, okay. So first off, does this sound like you? Are you ever known to be caught saying to your friends at lunch, my application is easy to unit test?
I don't worry about dependency bloat.
My code is clean. It has high signal to noise.
My tests never mysteriously fail when run out of order.
And I don't think I will have any of these problems either.
If so,
what the heck are you doing here? You're in the wrong place. Go outside. Enjoy yourself. This
seriously,
talk
go.
May not have much to offer you. No, yeah, go. Buddy, out. No, okay. We're going to talk about what Juice is and how you use it, and that's pretty much it.
And I'm going to progress the slides.
That's what he thinks. Okay, any questions? Okay,
good.
So we're done. Actually, no, wait. The reason that was there is because I wanted to point out that we will take questions as we go. We have tried very hard to make sure that we fill in all of the logical, we're trying to take you on a nice logical journey here from the simple through to the complex. So if we miss something, I got to stop doing that. So if we miss something, then we would rather hear from you so we can fill in that hole rather than keep on going and have you just be totally lost.
Speak for yourself. I'll take all my questions at the end.
Okay, I'll be doing all the questions in flight. And I know that everyone always says, like, I don't want to ask a stupid question. And, like the speakers are always supposed to say there's no such thing as stupid questions. But we all know there's such thing as stupid questions. And I'm here to say, please ask us stupid questions, okay? They're so much easier to answer, okay? So the stupider, if you could just ask us the stupid ones, then I can answer those. If you ask hard ones, you got to go to Bob. That'd be great. Yes?
Is this a stupid question?
I got to think about that. So that makes it a really good question. No, the question was, I have to repeat the question was, is this a stupid question? And I don't know how to answer it, so it's a very good question. I should give a prize for the stupidest question all day. Free copy of Juice. Oh, okay. He's making, yeah, because I wrote the slide, so I have to say it. So here is one angle to look at what dependency injection is. You can come at it from a couple different angles, and maybe one of these angles will work for you more than others. Here's the angle that we're coming at it today. The fact of the matter is that static references have problems. They can be useful because sometimes you don't know any other way to do it, but they make your code very tightly coupled. You have one piece of code in one module that's depending not just on the interface, but on the implementation of code in another module. It's not very polymorphic or object-oriented. You're sort of a restatement of the bullet before. It's also very global. If you have a static reference that you want to be available outside your package at all, you therefore are publishing it to the world. There's no such thing as like, these are the people who are able to obtain instances and these people aren't. They just reference your class and there they go. And really the big one for me is that it leads to all or nothing testing. If you write some code and you want to test your code, guess what? You're testing the connection all the way back to the database across all these chains of static references because you really have no other way of doing it. And the biggest problem is that static references force you to use other static references, which force you to use other static references. It's viral in the bad way, not in the YouTube way. And someone coined this term static cling. I don't know who that was, actually. It gets on you, and you can't get it off like the saran wrap. OK, Bob, whatever the next one is you're giving.
So I guess the idea is, what if we, right now with plain Java, you really have no other choice but to use static if you're just trying to do plain Java. So what if that wasn't the only option? And that's what Juice is going to enable. And I kind of like to think of these things in concrete terms. So how many of you have written a test, written a unit test against some static or against some code which used a static factory, and you have to pass in one. You have to pass in. So you start off the unit test, you you pull out the existing implementation of that static factory, and then you pass in your mock implementation, then you run your test, and then you have to remember to pass in the original implementation again at the end of your unit test, right? What happens if you don't do that? Anybody? If you don't remember to restore the?
Bad things.
Bad things. If you run your tests out of order, your tests interfere with each other. Sometimes they fail, sometimes they don't. And also, it results in a lot of boilerplate code, and it just adds friction to writing unit tests.
Stick to the slides, Bob. While Bob was talking, you probably read everything that was on the slide. Anyway, he touched on cleanup after tests, blah, blah, blah. We'd like to be able to think in terms of objects, because that's why we do object-oriented programming. Once you get static cling, you end up thinking in terms of procedures all the time. We'd like to fix that. But how? Does a factory pattern help? We didn't show a snippet of code for the factory pattern because I think everyone has seen a factory pattern. You have some piece of code that creates something and returns it as a type of, some abstract type. Does it help us avoid statics? Not really that much. You've still got to get the factory somehow. How are you going to get the factory? From a factory? I don't know. You're pushing the dirt around. You're also still having a compilation dependency on that implementation. If you want to build your code, it's going to build the factory, which is going to build the implementation code. You haven't really removed the dependency. You've just removed it one additional step.
And then you have all the boilerplate code. You have the factories. You have the factories, the hammer factories, and then like I pointed out on the last slide, you have all the boilerplate that's added to your unit tests. I mean, it makes your unit tests about twice as big to have to pass in a mock factory, clean up a factory. And then your unit test has to worry about three things, not just the code you're testing, the code you're testing against. It also has to worry about a factory.
You're on a roll, Bob.
Factory?
Does a service locator help?
So how many people are familiar with the service locator pattern?
Looks like about a quarter.
J2EE. So for those of you that aren't, the service locator pattern is basically the idea that, okay, the factory's not good enough because we still have this static compile time dependency on whatever the factory's producing. We need some kind of generic way to replace that. So the idea with a service locator is you can give it some token. It can be like a name, or it can be like a type or whatever, and it gives you back an object. So I can say, give me an instance of the mailer service, and the service locator gives you back an instance of the mailer service. One example implementation of a service locator is like JNDI. I'm sure plenty of us have used that.
So the problem is it's virtually just as static as anything else. You still have to get a handle to the service locator somehow, which means that your test has to do some setup before, then test itself, and then remember to revert it back again, and several of the other disadvantages of statics. It's also hard, if not impossible, to validate that everything you're going to ask the service locator for at runtime, you want to validate that stuff up front early on, and you don't really know what you could ask for anything at any time. It also makes it hard for your test to know exactly what setup the test needs to do. It has to start searching around through all the code that it's going to be testing and noting all the things that are going to be queried from the service locator so it can know to set those things up.
And then it also ties your classes to a single context, right? I mean, you have your service locator configured like one time probably for your whole application. Well, what if I want to use this same class two different ways with two different implementations of its dependencies?
So these methods are both sort of pull methods, where your client code is going to try to pull references to the objects it needs. And they sort of don't quite work. But what if there was a way that we could push instead? So that by the time your object code that you wrote is executing, you've already been given references to all the things that you're going to need. So that is what dependency injection is. It is an anti-static mat for your code. Like they sell at Fry's, you should always touch it first before you touch any of your code. And it simply injects, which means gives your objects the references to the other things it needs, which are its dependencies. That's it. Some of the things we like about it over the service locator is that you can look at anything and you can see right away up front what that thing depends on. And you can use those objects with or without the framework present. and your dependency graph is explicit. Now, these things, I'm stating them now, but you're going to see them illustrated with code as we go further. Still don't see many hands, so we must be doing well.
So what's juice?
What's this juice, then?
Yeah, that's Kevin's joke.
Oh, yeah.
So you can do dependency injection by hand. Really, the idea is it's as simple as Kevin just described it. It's don't call me, I'll call you. Your object doesn't call out to someone to get your dependencies. Someone passes them to you. But without juice, you also have to write the code to do the passing into, which, like factories, is a lot of boilerplate code, and it's a pain to write, and it's not quite as flexible. So juice saves you from having to write a lot of code, and it saves you from having to worry about things which we'll get into, such as scoping. And what else does it let you do?
I think we're going to find out.
Okay.
The main thing that we want you to understand about Guice is that it is a dependency injector. That is the only thing that it exists for. That's the only thing that it does in this world, except for the other thing that it does, which we're not going to be talking. So Guice also does some AOP stuff. We're not going to talk about the AOP stuff. We're just going to talk about Guice as a dependency injector.
Unless you ask.
Okay, so here we have an example of a complete running application that uses Guice. It uses Guice for absolutely no purpose in the world.
Yeah, if this code doesn't make sense to you, it's because it doesn't make sense.
Yes. So it is an example of the simplest possible application that uses Guice. Of course, this application did not really need to use Guice because it is so simple. This is the starting point from which we're going to start to build in more Guice concepts progressively as we go. Although we're going to add more interesting stuff to this example as we go, the examples are still going to be toy examples. That's because they have to fit on slides. And actually, we have, we're working on the beginnings of another talk, which would be sort of techniques for migrating real-world legacy applications to use Guice. That's sort of a whole complex topic in and of itself, so we're just going to stick to the basics here. So what's happening here is we have a class called greeter, and you're going to want to get an instance of it. What Guice is capable of doing is creating instances of things and doing lots of fancy stuff we're going to get to. But for now, it's doing no fancy stuff. It's just simply we're creating an injector, and we're asking it for an instance, and we're calling a method on it. That's it. So, uh-oh, that's really it. Oh, there we go. It truncated the slide. There we go. I think that's it. All right. We have a question.
You're probably going to get this later, but can I give it instead of get instance and I pass the class, can I pass it an interface and then it knows,
Oh, yes. Yeah, that class that we got could have been any type. Yeah, and we will certainly get to an example of that. Okay.
Let's make it a little more interesting.
Okay.
So as we explained in the last slide, there was really no point in using Guice. You could have just said new greeter. But now let's kind of see what Guice can do for you. Let's say, for example, greeter has a dependency on what we'll call a displayer. We don't want to just always do system out println. So the way you tell Guice that you want this dependency is you just use this @inject annotation. And you can apply this @inject annotation to, as you see here, a field, or also constructors or arbitrary methods. And then basically what's going to happen here is that our code up here hasn't changed at all, but behind the scenes, whenever Guice creates us this greeter instance, it will find an implementation of a displayer. It'll create an instance of displayer and pass it to greeter and then return that to us.
So this is, again, a working piece of code that displays hello world. Do we have a question?
Still pretty pointless.
Yeah. Can displayer be like private final?
Sure.
Yes.
Displayer could be private final in this case. I think that
Thanks to the magic of reflection, yes, you can.
yeah, these would
set a
really be
final
in
field.
3 different files that we tacked together into one slide. And the key thing to notice is the difference between the application and all of the code that makes up your modules of that application. And that application code, as we go through this presentation, is really not going to get very much more complex than what you see there. It's going to stay simple. All of the fun stuff is happening down below. What I mean by an application is this is basically the entry point to your application. If you have a command line application, this is the thing that has your main method. If you have a web-based application, this might be your main servlet. If it's struts, it may be your struts configuration that points to your module. I'm actually not going to be showing the application on most of these slides because it doesn't change too much from what you see here. All that it does is creates an injector, and then it does what we call bootstrapping. It's basically creating the injector gets all your stuff set up, and you just have to sort of hit the button that says now go and start doing what you're supposed to do. And we need some entry point into our implementation classes. So for us, it's say hello.
So ideally, this would be the only place in our application where we would come into contact with the injector. And what I mean by that is, so imagine if all of our classes in our application asked the injector for the implementations, for the dependencies that they need. What would we have? We'd have a service locator. So what sets dependency injection apart from service location is this idea of bootstrapping. And what I mean by that is, so we bootstrap our application with this kind of root class, and in this case it's greeter. But from then on, like I said, we don't have to deal with the injector anymore. Greeter has displayer injected into it. Displayer, like the implementation of displayer, has its dependencies injected into it, and then those dependencies in turn recursively have more dependencies injected into them. And the end result is we just have a bunch of nice, clean, unit testable classes. That's our whole application that don't worry about where they get their dependencies.
From the back?
On that previous slide, if a displayer needed parameters, how would that work?
The question.
He asked a great question. You're talking about if you needed to pass parameters in when you create the displayer, or? So he's asking, okay, so we have this class. We need some of the parameters injected as dependencies, but we also want to provide some at runtime in our code. And the best way that I found to handle that is, I'm somebody who likes to make everything final, right? So you could either let Guice create your object and inject all the dependencies and then call some setters on it. But what I prefer to do is use the builder pattern. How many people are familiar with the builder pattern? Good, pretty much everybody. The idea is you use this builder object, and you can kind of populate it piece by piece, incrementally, and then you create this object using the builder that's final.
I think we're getting into like an advanced topic that we don't have a slide about, so it may not make sense without the slide.
That's okay.
Maybe we'll work this into our next talk.
Yeah, definitely.
If that answered your question, great. If it didn't, let's go a few more slides, and I think you might see what you were looking for.
So the point I was getting to is you inject the builder object, and then you call a method on the builder object to create the final object with your runtime parameters.
And one more.
This will only give you one instance. Maybe you didn't want to use this instance of the display object.
We will definitely come back to that. He asked how you get more than one instance per injection. We will definitely get to that in a few slides here.
Okay. So first, we're just going to give you a quick tour of the fact that we have field injection. We also have, whoops, I went the wrong way. We also have method injection, which works the same, but you put the inject annotation on any method that you want. That method can have as many parameters as you want, and Guice will try to satisfy all of them, and it will call your method.
And there's also no need for it to be a setter method. You can name your methods anything you like.
Named anything you want. And thirdly, we also support constructor injection.
My favorite.
Yes, Bob's favorite, my favorite, the favorite of the elite. I don't know.
Immutables.
The reason that Guice supports all three is that each of them have their relative pluses and minuses, which we will try to get to at its slide near the end, if we can. But just know that whichever combination of the three you decide to use, they'll all work. You don't have to configure Guice and tell it which kind you want to use. You just do what you want. It will try constructor injection, then it will try field injection, then it will try method injection, and it will all happen. So constructor injection, you may have one constructor that has the add inject tag on it. You may not have two, because we don't want to guess for you which one to call. And other than that, it works much like the method injection, in that you can have as many parameters as you want. But the really nice thing is in green, because now we can finally, we can make our fields final, which is nice. because when our code starts executing, we know for a fact that they have been set and they won't change. Question?
I'm getting a little lost here.
Okay.
What does really it mean to put inject at the beginning of the constructor?
Okay, so inject is a tag which you can stick on any of your fields, your methods, or your constructors. And Guice will never call any of your code that doesn't have this tag on it. This is how you tell Guice, I want some dependencies from you, and this is where I want you to send them. So in this case, we're saying, we don't have any methods we want you to inject. We don't have any fields we want you to inject. We just want you to call this constructor when you want to create our class. And if you have no constructor that has inject on it, Guice will just use your default parameterless constructor to construct your class. Okay. And this just shows you that you can have multiple parameters, as I was alluding before.
This is really where Guice shines versus other frameworks and versus doing dependency injection by hand. This initial setup that we've shown, yeah, it's kind of like, it looks like a lot of work for a little benefit, but what we really built Guice for is kind of like development scalability. As you know, you're going to create these dependencies one time, but you're going to use the dependency probably 100 times, right? So in this case, you can see if we want to, all of a sudden we want to add a dependency to our class, we just add it to the constructor and take it.
Okay, I'm going to try to speed up a little bit without speeding up too much, just because I think we're about a third of the way through our slides.
So someone earlier on asked about this. So what if we want, we don't want to depend on a concrete class, because that's hard to test, and we have to know about that class at compile time. What if we want to ask Guice for an interface and have it give us a concrete implementation? And so as you can see, we're kind of starting that refactoring here. We've extracted, and all we've done here is it's our previous example still, but we just extracted an interface out of displayer and renamed the implementation standard out displayer.
Now let's try to run our application. And we get an error because we never told Guice how to figure out which implementation we were going to want to use of that interface. So it tells us that, and it tells us that it wants something called a binding. So we're going to learn what a binding is. In order to learn what a binding is, we first have to tell you what a module is. Modules are how you supply extra information to Guice that it cannot glean automatically from your code. Some things we've seen already it can just get from looking at your code. If there's more it needs to know, that's when you use a module. A binding is the most common example of something that you would put in a module. Binding basically takes a particular Java type, whether that is a concrete class or an interface or an abstract class or enum, whatever you want it to be. And then you associate information, various configuration options to Guice that deal with that type. In this case, you're telling it, use this more specific type. Whenever somebody asks for the more general type, go to this more specific type. When it goes to this more specific type, it'll see, this is a concrete class, I know how to instantiate it, and you'll be off and running.
Does everyone see what's going on here? Great.
The other thing I was going to say is that Guice, what you're binding on the left and what you are injecting with the inject tag, those types have to match exactly. We don't do any guesswork for you where we say, well, you bound this subtype and you're asking for a super type, so we think this is the one that you want. It's totally a literal match. And now we simply need to tell our application, remember the application? We haven't seen that in a while. This is the only modification we're going to make to this application during our whole talk. We're going to add a pointer to our module in it. And then this is going to be our application for the rest of the talk. And now our code works. And I put this little, that was sort of like a, what's the word for that? Like a little dig, maybe. So like to us, the idea that you write some code and then it doesn't work until you go and write some XML is annoying to us. So we like that you can stay in the Java world as long as you want and make your code work. Okay. Did I, wait. Whoa. Okay. Do you want to go?
Oh, go ahead.
Okay. Oh, you said me go ahead.
Yes.
Okay. So we showed a picture of your application including a module. And this relationship is many to many, and that's key to the whole idea of a Guice-based architecture. You can write a module one time and include it in as many different applications as you want, and your applications can include as many different modules as they want. Your module can be as granular as you want. If you want to do every single binding that you ever make in its own individual module, then you'll have lots of control to pick and choose exactly what you want. If you want to group things together because you figure, nobody's going to want 3 of these without wanting the other 2 as well. They kind of go together. So you group those together into a module. The module is simply the unit that can be composed into applications.
And the original driving factor for this was Kevin and I worked on AdWords together, which is, as many of you know, a multi-million line application. And it's really hard to check that all out and build it all at once and run the test against it. It takes a long time. So what this enables us to do is that we can break AdWords down, or any big application, down into multiple modules that have no compile time dependencies on each other. And then what that in turn enables you to do is you could just imagine being able to just check out one module, and instead of installing the other real modules that pull in another few million lines of code, you can just install these like fake modules that provide just enough implementations for you to be able to compile and test your code.
Okay, and you can use modules to install other modules in a tree type of structure. You may or may not want to do this. I don't personally like doing this because for me, the whole point of this architecture is to keep your modules from having compile time dependencies on each other, to keep them independent. So if you start having one module that installs 4 that install each 4, and then they each go and sell Tupperware or whatever, you have just left yourself in the same situation you were already in of a big connected mass of code.
It's mostly for the ability to do that. It's mostly so you can do utilities, like someone just sent out some code that can integrate with our flags framework and automatically create bindings for all of those. So you don't have to have these static dependencies on flags anymore. You can just have the flag values injected right into your code. So imagine how much easier that makes testing, right?
Questions? Okay. Whoops. Okay. How do I use Guice to unit test? It's a trick question because you don't. What happened is that Guice led you naturally to create your test in such a way that it's trivially unit testable. Because in your test, you simply instantiate your class directly, and you pass in whatever, whoa, don't do that. Okay. You pass in whatever implementations you want it to depend on. If you want to take a handful of real implementations and connect them all together and test that, you can do that. Or if you'd like to test, as would be a proper unit test with a capital U, if you want to test just your class by itself, you pass in a mock implementation of the dependency. So you see in this example, we're not invoking any Guice-specific code at all. If there are any questions in the back. Presumably, it doesn't work for field injection. Very astute observation.
Not just presumably.
This is why field injection is. What kind of language are we capable of using in the field injection? Is bad. Sucks. Yeah. It has its uses, but it is not testable because in order to make it so your test can set it, you would have to make it public. But guess what? You can't make it final because Guice needs to inject it after it creates your class. So now you have a public non-final field in your code, which I don't think anyone really wants. Jesse.
I heard you guys just added field injection for slides.
Field injection is great for slides.
It does
yes.
make your code concise.
Because, okay, field injection is the most compact way to do an injection. That's why we use it on slides. That's why sometimes I cheat and use it, but it's not that great. Okay. Hello? Okay. Of course, some would say that an interface with only one implementation is like a cactus with only one fishing pole, because it doesn't really make any sense. So let's say that we have our displayer interface. We want to have not only this font is really small, isn't it? We want to have not only a displayer that displays to standard out, but let's just have another one that's similar that displays it in Times Square on the big electronic billboard. Same interface, you're doing the same thing, just one goes to a screen, one goes to Times Square. So we have to figure out how we're going to tell Guice about both of these. If we try to do just the naive thing and just bind them both, we get this error. A binding to example.displayer was already configured, and it gives you the line number both where you first configured it and when you tried to configure it again.
If you use an IDE, it'll automatically link these too.
Yes. So we can't do that. And if you have two different modules, they can both bind the same types, and that's fine. But if you try to put those together in the same application, that's when you get the exploding. So it always looks like it's skipping a slide when I do this, but it's not. OK.
So other frameworks, well, when I used to write service locators, I would typically differentiate these things with a string. Other dependency injection frameworks tend to do the same thing. And one of the new ideas that Guice introduces, and this was actually Kevin's idea, is instead of using these arbitrary string identifiers, we can use annotations. And I can't tell you how great of a fit this was. And so the basic idea is that instead of just binding displayer directly to an implementation, now we use this combination of both the type, displayer, and what we call a binding annotation. This is something that kind of describes the binding. And in this case, Kevin used for standard out and for times square, two annotations to differentiate between these two. So in your module, when you're configuring these things, as you can probably see by now, Kevin.
I was moving to the module because I heard you say in the module. OK.
So in the module, as you can probably see by now, Guice uses this kind of like nice little expression language, and all these types are checked and whatnot. So you say bind displayer annotated with for standard out to whatever implementation you want to use for that. So now when I want to go use this thing, it's really nice and clean. Instead of just doing @inject, I also include the binding annotation. So, and as you probably know, like the benefits here over arbitrary strings is that it's more concise. You don't have spelling errors and whatnot.
Yes, you can, if you're looking at the annotation in your IDE, you can find usages to find all the places that are using it, et cetera. And the thing I want to point out is that we're showing you the simple case first. The simple case is the case that each client knows at compile time which flavor of implementation it always wants. So we're going to look at a more complex example maybe next. Not next, but soon. Where do these binding annotations come from? Well, you just make one whenever you want one. They're yours. You put them in your package structure where you think that they belong. And some people have some trouble getting used to the idea of creating a lot of these things. But annotations, what I want to emphasize in green down there is that annotation types are cheap. They don't really cost anything. Create 100 of them, create 1,000, I mean, whatever.
Well, and the truth is, a lot of those people, I think, are coming from the string world, where you have to have a unique identifier for every single binding that you would need in another framework. Whereas in this case, you can reuse these annotations across multiple bindings. Like we might have a binding named @transactional or @secure or @active. And you can reuse that core annotation multiple times.
@read-only.
@read-only.
Yeah, et cetera. OK, question in the back first.
Yeah, so with those annotation types being class names, then you need to declare a class of that name, and what about packages for it?
Yes, so these 4 lines in the middle of the slide, this is what the class looks like. So you create a file called 4timesquare.java, and these are the 4 lines that go in and the import statements. And package location can be wherever you want it to be. Basically, you're going to be binding an injection that uses this annotation as part of your API. So people who want to use your API are going to want to be able to find this. So you locate it close to the other stuff that it works with. I don't know how to make it more specific than that, but usually when you look at a particular case, you can decide where it belongs pretty easily. Pardon? I said basically these are the only 4 lines in the file, and then I added, well, you would also need the import statements for retention, retention policy, et cetera. But this is basically what the code you write looks like. Yes. And good. Oh, finally, we get a stupid question. OK.
It's mine.
Oh, no, me.
My turn.
How is this better than, say, having a class with a bunch of static strings on it and using those as your annotations?
Well, it's really, can you go back to the previous slide?
That's not that stupid of a
It's not
question.
stupid at all.
No.
Can you go back to the? Can you go back to the previous
Okay.
slide real quickly?
Okay, so the question is, how is an annotation really better than a string anyway? Because you can always define string constants, and you can reuse those same string constants just like you reuse an annotation. Did I sort of get that right? Okay, you want to look at this one?
Yeah, so I just wanted to kind of pull this up. You couldn't do something like this necessarily with a string constant. So that's really kind of where the annotations shine. And what I'm pointing out here is that you put the binding annotation directly on the injection point. And in this case, it's directly on the field. If it was a method or a constructor, you would put it on the individual parameters.
Parameter. Okay, and this one.
On this slide, you define the display module, and new greeter is using the binding to the display module, but where do you register the display module?
In the application, good question. Okay, repeat the question. If you look at just this code, you don't see what connects up the fact that we're using for times square the annotation up in this module, and we're using for times square the annotation down here in this implementation code. You can't really see what connects those together. And the answer was back a few slides when we talked about the application. This is where we say, for this application, we'd like to use display module. And then I might also write fake display module, or any other type of module, and somebody else's application might use that one. But because we're running with this module in place, and we're bootstrapping this this greeter class. Is this where we were? Yeah. That's how it knows. Did that help?
Yeah, so you will just say juice.create injector, and you will not necessarily use the return injector right away. It was there in the system.
Usually when you get the returned injector, so the question is, after you create an injector, do you have to do anything with the injector, or do you usually not? And usually there's just one thing that you have to do to sort of touch off everything. And so in this case, we just get an instance of greeter class and call .sayHello. But even if our application was much more complex, it might look like get an instance of servletengine.class and call servletengine.start. But you still, once you do that, then we just discard the reference to injector because we don't need it anymore. Okay, one more question.
Let's say you have 5 inject tags, you're asking for display, or does Juice create 5 instances of display, or is it
We will get to that. Yes, the question is how many times does Juice create instances, or does it reuse instances? Is that the question?
Yes.
Okay, we'll come to that soon.
Very soon.
Yes, okay, I'm gonna move on. Multiple, using, creating. Okay, is it your turn now? I forgot.
Blah, I don't want to talk about this. I didn't want to include this slide.
If for whatever reason you don't want to create an annotation, you can use a string name like this. Just make sure that you spell it times square exactly the same way in both places, or it just won't work and you'll have no idea why.
And actually, this is kind of a useful slide in that it illustrates that annotations don't just have to be markers in Juice. They can actually have attribute values, not just one attribute value, multiple.
Which we'll cover in our advanced
Absolutely.
tech talk, which will be given at an undetermined date and by an undetermined speaker. Okay, constant bindings. So now it's your turn, right?
So I can touch on this.
Okay.
So there's a lot of situations where you have this like configuration information, ports, host names. Say you want to specify a class to use in a properties file or that sort of thing. Well, Juice addresses these separately in what we call constants. And it looks very similar to the binding code we've already seen, except for the fact that you don't have to specify the type. And the reason for that is that Juice can figure out the type from the value.
And we'll probably we have to move quicker. So
we can definitely do that.
So has questions on this?
Kind of the one interesting thing here that I just want to point out, Juice has support for type conversion. And it can convert strings to any type of primitive type, classes, enums, that sort of thing. And where this becomes interesting is, as I said, sometimes you want that external configuration. Juice can do something like slurp in an entire properties file and then automatically figure out every place you need those properties based on where things get injected, and then it'll convert those and check their types at startup. So that's kind of one of the interesting factors. As you can see here, like we bound a string to that annotation, but Juice is still able to convert that string to an int and inject it.
Okay. Now, I mentioned that we showed a simple example before when the client always knows which flavor it wants. Does it want the times square displayer? Does it want the standard out displayer? But sometimes if the answer to what dependency do you want is, well, it depends. And so here's an example of a class of a method called get, which picks based on whether it's Tuesday. If today is Tuesday, I must want to go to Times Square. If it's not, I must want to display it on the standard out. Now, how would we get Guice to make use of this logic somehow? And the answer is, if Guice doesn't know what it's supposed to do, you just tell it who does know what to do. So this class that we just created called displayPicker, we bind it using this toProvider directive here, which is, I think before we were using just .to, so now we specified that it's toProvider. And then with the displayPicker class, all we have to do is make it implement the provider interface. And since we already named our method get, because I cheated that way, we didn't even have to rename the method. So now, because we've done this, Guice will use this class to figure out how to get instances of displayer. And this class itself is a first-class citizen. It can have things injected into it. When we talk about scopes, it can have scopes. It's just a class like anyone else. It just happens to have this extra capability of being able to provide other types. And I saw a question from Jeff.
You wanted to inject the clock there too, right?
Yes. In real life, I would never do this. I would always inject a clock. And I would get the time from the clock because that would make my code testable. On Wednesday. I could test the code on Wednesday, yes. This is a perfect example of what not to do. Thank you very much for embarrassing me horribly. No, I'm kidding. I don't use clock on slides, but I use it everywhere else. Question in the front.
Yeah, the module binding that happens on Startup as far as I know. So this code will actually choose to play based on which day it's done.
So the question is, would this code choose an implementation based on the time that it currently is when you're requesting it or the time when the application was started? And to understand that, we really have to understand the idea of scopes.
Or you can just tell them the answer.
Or you could just tell them the answer. If you don't use scopes, which at this point you aren't because we haven't covered them yet, then every time that Guice needs a provider for this, it will create it again, and it will call it again. So basically, you're going to get the current time. But if you have some class that needs a displayer, and then you hold on to that class for a long time, and you hold on to that displayer reference, then, yeah, of course, then in that case, you will be still getting the old behavior. So that's a good point. Did I remember to repeat the question? I forgot.
Yes.
Oh, well. And question near the back.
How do you provide a parameter to display picker so that it can use that parameter to decide which?
OK, so the providing of a parameter, that is an advanced question, which we will not have time for in the talk. But the answer is that it's kind of hard, and in Guice 1.1, it'll be kind of easy. Is that right?
Provide a parameter?
Well, we don't. So I deliberately chose an example where I could switch just based on information I could find without needing something to be told to me about the context in which I was being injected.
Yes. So he's asking, so you have some context that you want to pass in and decide which one to return based on that?
It's our biggest missing
So here,
feature.
this is kind of a convenience for us, right? I'm sorry? So yeah, you can do that. This is kind of a convenience here, being able to bind, like right now we're not binding provider of displayer to this. We're binding just displayer. So the users aren't getting this provider. The users get a displayer. And and every time that we need a displayer, Guice is going to come to our provider. But if we get a little more complicated where we got to pass in a parameter and stuff, then you just, instead of doing this and injecting displayer directly, you need to inject kind of like some kind of intermediate class.
OK. Let's see. Introducing, that was supposed to say custom provider, but anyway. The slight problem here is that you see calls to new. And when you see calls to the new keyword, that's a signal to you that, guess what? Guice is not the one who's instantiating these classes. Hopefully that will be obvious. My code right here is instantiating these classes with the new keyword. And so I could have peppered @inject annotations all over times square displayer and standard out displayer, and nothing will happen because Guice has no idea that these instances even exist. So this is an example of a sort of a best practice with Guice, which is try to let Guice do as much of the instantiating of things for you. If you want to be stubborn about it and say, no, I want to instantiate my own stuff, go ahead, but it will just be a little bit more confusing and a little more difficult. It's better if you can sort of accept Guice into your life as your own personal instantiator and just sort of get over that, reluctance, and then you'll be happy. It's the only thing standing in between you and happiness. And I use the expression a lot, in the club, out of the club. It's sort of this exclusive club. The objects that were instantiated by Guice, they get all these features. And then the ones that you instantiate yourself, well, they're like these second-class citizens. So there are workarounds for dealing with that, but usually the way to proceed involves figuring out how can we make it so that Guice is the one creating this class. And you can think of it as a complement to the garbage collector, which is where things go to die. Guice injector is where things come from to live. So I, made my famous joke where I said I was going to rename the injector to be the garbage producer. So you'd have garbage producer, garbage collector. Yes, I think that was on the Tonight Show, wasn't it? Yeah. Sasha first.
Can Guice eliminate the switch statement?
I put the switch statement in deliberately because I knew that my friend Sasha would love it. There's a question in the back.
So, to get this particular thing in the club, would you have to pass your injector all over the place?
Interesting question. Let's see how we would get this thing in the club. Thank you. One way we could do it, and the question is, would we have to pass the injector all over the place? And the answer I always use to that is, I hope not. Let's try to see what we can do to avoid that. And that's our last resort, because when you do that, then you become Service Locator, and it's not pretty. So here's a case that works. You just, you have two instances injected into you, and then you return the one that you want to return. So I mentioned earlier that the provider classes are bona fide objects like everyone else with the same rights and privileges as everyone else, and that includes getting things injected into them. So this works. We don't even have to change the module at all. And the only problem is that it is a little bit dishonest about its dependencies. It tells you that it always depends on two things, but it might not ever use one of them. And you're going to end up having to create both of those things a lot anyway. So
that would suck to construct Times Square every time when we're just trying to print it.
We don't want to open the, wire connection to the little box at Times Square when we don't have to. So unfortunately, I won't be able to spend the kind of time on the next slide that I wanted to, but the solution is a little brain twisty. We're having providers injected into our provider. So let that percolate through your brain for a little bit. Provider is just an interface. It just means something that can provide. So you can use it in two ways. You can implement it when you have something to provide, and you can ask to have it injected into you when you have something that you need to have provided to you. And I just confused myself. And
I knew we should have named them two different things.
By doing that, we go down here, and so I only call the get method on the provider when I know that I'm going to need it. I can't highlight. I only call the get method when I know I'm going to need it. That way I don't do any early initialization of anything. This is called provider injection. It's an important feature that gets explained more on the next slide. Anytime that you can inject a foo, you can always inject a provider of foo automatically. You don't have to make a special binding, say, this is what you do if someone asks for provider of foo. It just works. And we saw one reason why you'd want to do it. Another is that your class might need to get multiple instances of this object over and over, and this gives it a way to do that. And you can also be ultra lazy, like we just showed in the previous example also, and only only initialize your database connection if somebody happens to hit the link that says whatever. I didn't think that example out very well. Questions? We're using, yes, Laura.
What is that last sentence?
If you bind a provider, and you also inject a provider, they may not be the same provider. So it's a little bit head exploding. But we use provider in two different ways from two different angles. And you can't assume that because we wrote a foo provider class and we're having injected into us a provider of foo here, that it's necessarily the exact same thing. Guice puts it through a whole bunch of decorators of proxies, of wrappers of proxies, of decorators, and whatever. Okay.
Walter.
On your last slide, you introduced 2 new providers, but do you also have to implement them too?
He said on the last slide we introduced 2 new providers, these providers that get injected. He asked if we also have to implement those, and the answer is no. So long as you have bindings for Times Square displayer and standard out displayer, Guice automatically provides providers of those to you.
And
really all those do is just call us right back into Guice.
And over here.
So regarding the, I guess, injection of generified things, this kind of implies that there's no problem. If I want to inject like iterable string, will that work?
Absolutely. He asked about generic types. So is there a difference between list of string and list of user? Yes, Guice does see those differently, and you can bind them separately.
Not only can you bind them separately, but if we were using a non-generics aware framework, we could declare add inject list of user, and we could later bind a list of string, and it would just pass it in. And it would not even know that anything was wrong until later when we tried to get from the list, and then it would blow up. So that would be really bad. And that was one of the things that, one of the many motivations for us writing Guice to begin with, by which I mean Bob writing Guice to begin with. Guice is generics aware. It'll be in the advanced slide deck.
And that's actually thanks to Neil Gafter for coming up with some
Yes.
tricks to get around erasure on that one.
Okay, I feel bad that we don't have much time for scopes. Should
We
we?
have plenty of time.
Plenty of time. Have a lot of people been holding back questions that they want to wait for the end, or have they been asking them as they go? Okay.
So this to me is one of the most important features of Guice, and it was one of the main reasons I created it. I was building web applications, and how many people here build web applications? There you go.
Do we do that kind of thing here?
I think. So I got so tired of writing this code to look on the session. If I didn't find the object on the session, I'd create it and then put it on the session and then return it. And you had to make it synchronized, and same with the request. So what Guice does is it enables you to look at scopes like that, like request scope, session scope. Singleton is a scope. It enables you to look at these and describe these in like a declarative way. So what I'm saying is I can take any provider, I can take any binding, and say I want that binding to be session scoped. And what Guice will do for you is anytime say I say bind foo to like foo impl in session scope. When Guice sees that, it will every time it injects, it'll automatically do that work of going to the session and see if there's an instance already there, and it does this canonically. And then if there isn't, it creates one. If there is, then it returns the existing one. So, and the nice thing about that is you don't have to go through and write the same boilerplate, lazy loading code over and over again. It's completely declarative and reusable.
So by default, there's no scope, and that means that every time that Guice sees a request for an injection, it creates an instance, injects it, and forgets it. Next time, creates a new one, injects it, forgets it. A scope is nothing but a policy or a strategy for how instances should get reused. Singleton means once you've got it, always reuse it. And session means look in the session. If you have one there, reuse that. If you don't, create it and put it in the session, et cetera, et cetera. That's really all that we're talking about here.
And these are terribly easy to write too. You can provide your own custom scopes. So you can imagine like a transaction scope if you wanted to cache objects for the current transaction.
Singletons have gotten a bad name in many circles because of the pattern of having classes enforce their own singletonness. The problem is that it creates difficulty to think of singletonness as something a class is. It's better to think about it as a way that you use the class. And that means with Guice, you use your module to configure that in your application, you would like to use this as a singleton. And then Guice will do it all for you. But somebody else's application could do something different, and your tests can always do something different. Your tests can new up as many of these things as they want to. So if you use Guice's concept of singleton, then all of the laundry list of complaints about singletons that I just saw in the bathroom, when I was in the bathroom above the toilet, they go away.
Testing on the toilet.
Testing on the toilet, we love it. 2 ways to make a singleton. I guess you'll have to refer to these slides later. 2 ways to make an eager loaded singleton. Refer to these slides later. We have 2 minutes left. Talked a bit about web applications.
So this kind of goes back to the whole bootstrapping thing. It's like, so we saw how to bootstrap like a command line application. It's how do you do a web application? Well, we provide integration with Struts 2, for example, so that every one of your actions is automatically injected. So really, if you're using a Struts 2 application, you never have to deal with the injector.
Hopefully.
Hopefully.
Questions on this slide? Also, when in web application land, there are a couple of scopes that Guice provides in a subpackage called com-google-inject.servlet. They are request scoped and session scoped, and in the future we hope to have conversation scoped. I describe these as a two-way guarantee. All scopes are like this. It not only guarantees that one instance will get reused for all requests within that scope, but it also says that the instances will not escape from that scope and get used, for other people. So it's a pretty useful thing. And skip the last bullet because it's complicated. Here's some stuff about how to choose a scope. We're out of time. Here's some stuff about whether you would use field or method or constructor injection. We'll tackle this at the beginning of our next talk, and we'll put the slides up on.
Quick rule of thumb, I pretty much always use constructor injection unless it doesn't work.
Yeah, me too. So there you go. Just use constructor injection.
Unless I can't.
Ah, we made it. So good job, Bob.